Hello again, this is a quick update from yesterday's video with Devlog number 3, where I talk about the AI's inability to chase or keep the puck. So I did some quick experiments with the reward function to train the neural net to keep the puck and nothing else. So no goals, no shots, no nothing. The result you see is after 6 million time steps of training. It keeps the puck for a good minute or two before losing it. So that's some good progress. As you can see, he's going to lose it soon. There you go. So let's take a quick look at the reward function code. So how I make it work is that I calculate the distance between the puck and the player, as seen from yesterday's video. When the distance is getting bigger, I punish the AI. And when it has the puck, or almost has the puck, I give it a slight reward. Before I was giving a reward for getting nearer the puck, but it didn't work as well. I need to do some more tests to make sure the problem was caused by this, but or it's because of some other reward calculations that was getting in conflict with this. But what might have happened is that by giving a strong positive reward for getting near the puck, it has some incentive to actually lose the puck and get near the puck afterwards, and back and forth like this. So maybe that would happen, but I need to do some more tests to be able to confirm that. And to make it work, I need to add some punishment for having a goal score against the AI. And the reason being is that when I don't have this line, I don't consider the player 2 score, is that the AI took the puck and ran into his own goalie to score the goal. And why he did that is because that was a sure way to avoid the other player to take the puck, because when there's a goal, the NHL 94 AI stops functioning, so the puck stays safely near the player. So actually, it found a loophole. It was constantly ramming into his own goalie and staying there. So another important modification I did to the done function. So like for the reward function, I calculate the distance between the puck and the player. So when the distance is bigger than 300, so when it's far away from the player, I stop the session right away. So before I stop the session almost at the end of the period. So this saves a lot of time, and probably that's why we can train it in only 6 million time steps. Because when the puck gets that far, there's very little chance that the player can catch up, that the AI can catch up. So there is no room for proper learning. So basically, it's a wasted training time. And now you might ask, okay, that's good for one-on-one, but what happens on the ice rink that is full with all the players? So I train a model for 15 million time steps with the same reward function, and actually learned to keep the puck, but it learned by finding a loophole, unfortunately, which is not great because it doesn't learn really how to avoid the other players. Just learn how to get that loophole. And that loophole is going in the corner of the ice rink. You see the NHL 94 AI has trouble with that, but eventually catch up and gets the puck. But soon he's going to get the puck back and restart the process going in the corner of the ice rink and avoiding. So it's pretty smart, yes, but it's very short-sighted because it doesn't learn any skills really. So for that, I think I'm going to punish it to go in the corners of the ice rink. Hopefully it's going to solve the problem. We'll see. So that's it. If you have any questions or comments, please ask down below in the comment section.